All right, let's look at some of these problems on the L'Hopital's rule worksheet. Okay, the first circle one, number 3. X goes to 0. First thing you always want to do on these is plug the number in and make sure, plug the number in and see what happens. On this one, if you plug in the 0, sine of 0 is 0. 5 times 0 is 0. Cosine of 0 is 1, and x is just 0. So what we get here is 0 on top and 1 on bottom. So my answer is just 0. So no L'Hopital's rule needed. I threw this one on here just to kind of remind you, use L'Hopital's rule, but only when you have an indeterminate form. All right, let's look at 6. Again, first thing to do is plug that 0 in. If you plug in 0 for x, the top becomes 0 plus 0. The bottom, the important thing to remember is sine of 0 is 0. Cosine of 0 is 1. So this gives you 0 plus 1 minus 4. Minus 0 minus 1. So this one's 0 over 0, and we need to use L'Hopital's rule on it. All right, so we'll take the limit as x goes to 0. Okay, on top, that's a pretty quick thing to do. Derivative of that's going to be 6x plus 15x squared. Across the bottom, we're going to have to use the chain rule on this first one. Derivative of sine 4x is cosine 4x times 4. Derivative of cosine is negative sine. Derivative of negative 4x is going to be minus 4. Derivative of 1 is 0. So now we'll plug the 0 in again and see what we get. Up top we get 0 plus 0. On the bottom we get 4, 0 minus 4. So this one is a 0 over 0, and we've got to do L'Hopital again. All right. Up top, when we take the derivative, we get 6 plus 30x. And on bottom, let's see. Derivative of cosine 4x is going to be negative sine 4x times 4. And we've already got a 4 on there, so this is going to be minus 16 sine 4x. Derivative of sine is cosine. And derivative of 4 is 0. All right, so after doing that, we plug our 0 in again and see what happens. Well, if we do that, on top we get a 6. And on bottom, we get 0 minus 1. So our answer here is negative 6. So in some of these, you have to use L'Hopital's rule several times. All right, let's look at 11. Problem 11. Again, this one we've got x is going to infinity. So when x goes to infinity, 4x plus 2 goes to infinity, and thus natural log of that goes to infinity. And essentially the same thing happens down here. So this is an infinity over infinity type. So we will use L'Hopital's rule. I'm going to change to black. Now, L'Hopital's rule, when you take the derivative of natural log of 4x plus 2, you get 4x plus 2 on the bottom, and you get 4 on top. And downstairs, when you take the derivative of that, you get 5x plus 3 on the bottom, and 5 on top. And of course, the derivative of 1 is 0. So let's see. If we were to think of this like this would be a 0 over 0 type. Because as x goes to infinity, up here this would be 4 and this would grow large, so that would be, this upper fraction would be 0. And same thing would happen down here. But here's what I want to do. Let's get rid of these double fractions. So I've got 4 over 4x plus 2 times the reciprocal of the other one. So if I distribute that 4 and 5 across, I get 20x plus 3, or no, 20x plus 12, and then 20x plus 10. And if I wanted to, I could use L'Hopital's rule again here. What the heck, let's do that. It's kind of overkill, but it works. Because it gives me now, I've got 20 over 20, and that's just 1, and that's my answer. You could also come up with that from back here. If you look at this and you think back to the stuff we did back in the beginning of the semester, this is a limit as x goes to infinity of a rational function. And since it has the same degree on top and bottom, we would just look at the ratio of the leading coefficients, and that ratio is 1. So that would also give us 1. All right, let's also look at 16. 16 is this is an indeterminate form, but this one is infinity minus infinity. So let's, well, first up, let's just look at what happens when x grows large. X squared is going to grow large, positive. And x is going to grow large, negative, but we're subtracting it off. So if you sort of look at all the signs, x squared, this becomes positive infinity. And then we're subtracting x, which is negative infinity. So you wind up with really infinity plus infinity. So that one's just infinity. And that's all there is to that one. While we're at it, let's look at 15 too. X is going to infinity. And honestly, I could have done 16 a different way. I could have looked at it and said, this is the dominant term, so it's going to win. And when x goes to negative infinity, x squared goes to positive infinity. And I'm going to do that same thing up here. X to the fourth is the dominant term here. So when x goes to infinity, all we have to look at it is x to the fourth. That's also going to go to infinity. All right.